Hello again, Year 7. I'm here again with some more extension activities for you. So today we are doing investigation of unseen triangles. So you can see we have a building pattern here of triangles. These triangles are made up of matches. So each side has 2 matches on it. 1, 2 matches, 1, 2 matches, 1, 2 matches. So around that first triangle, there are actually 6 matches, 2 on each side. Now the way that these triangles are connected together, when we put the second triangle in there, we overlap them a little bit so that one of those sides of the second triangle we can't actually see. So when we count the matches, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 matches to make the 2 triangles next to each other. Let's have a go at the 3 triangles, counting all those matches up. So just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 matches in the 3 triangle pattern. Now, can we see a pattern here so we don't have to keep drawing out these triangles? How many matches would it take to make 4 triangles? Well, you can see as we go along here, along this row of numbers that I've written, each time I'm actually adding 4 more triangles to the pattern. So for 4 triangles, I would need 18 matches because 14 plus 4 is 18 matches. What if I want to skip a few and go all the way up to 10? Well, that is adding on 6 more triangles. So that is 6 times 4, for 4 extra triangles each time. That's 24 extra matches that we need to add on. And if I do the 24 plus the 18 that I already have, 4 plus 8, that makes 12, carry the 1, and that will make 42 matches for 10 triangles. Okay, question 2, very similar. It says complete these additional parts to the table. We have already done a lot of them. We've done 1 triangle is 6, 2 is 10, 3 is 14, 4 is 18, and 10 is 42. So we've already filled in that far. Now they're wanting us to fill in a few extras. How would we get all the way up to 100 triangles? What we want to try and do is we want to try and make a rule that is always going to work. Now the trick to finding a rule is that as long as we are going up by 1 triangle at a time, the amount of matches that I'm going up by each time is what I need to multiply by. So I'm going to write this down below here. My rule is going to be the number of matches is going to be equal to 4 times the number of triangles. Okay, and I simply got that because that is what this was going up by. They're going up by 4 as I increase by 1 triangle each time. But multiplying the number of triangles by 4 doesn't give me the correct answer. 2 times 4 gives me 8. 3 times 4 gives me 12. You can see there is still something else that I have to add on, and it's the 2 extra matchsticks that I need to add on. So if I go 4 times 2 is 8, I would need to plus 2 to get to 10. 3 times 4 is 12, plus 2 more gives me the 14. So once you've worked out what to multiply, use what you've got to help you work out what you need to add or subtract on. Now that I've worked out that rule, let's use it to find out what happens for 100 triangles. All I need to do is multiply 4 by the number of triangles. So 4 times 100 is 400, plus 2 means that I would need 402 matches to make that pattern. Okay, to fill in these last 3 boxes, we actually need to go in reverse. How would I take the number of matches that I have, which is 26, how would I go backwards to find the number of triangles that would make? Well, we want to reverse the rule that we've written here. We went 4 times the triangles plus the 2 extra matches. So to reverse that, we want to go the number of triangles is going to be the number of matches in the reverse order. We would need to subtract that extra 2 off first and then divide by 4 to find the number of triangles. Let's test that. So going from 26, first of all, subtract off 2 makes 24. 24 divided by 4 makes 6. Okay, that works. And you can try it again going forwards if you want. 4 times 6 is 24, plus 2 makes 26. Okay, using the backwards formula again for the next one. 46, I want to subtract 2, makes 44, and 44 divided by 2 is 11. And one more time, for 102, subtract 2 is 100, divide 100 by 4 makes 25. Okay, so it can be tricky finding some rules for some of these ones. On to question 4. If you are asked to make a slightly different pattern with the matches, like the one drawn below, can you predict the number of matches required to make 10 mountain peaks? Show how you worked it out. Well, for starters, our triangles have changed size. We no longer have 2 matches on each side. We now have 3 matches on each side. Okay, and the other change with this question is that we're not comparing the number of triangles. Well, we kind of are comparing the number of triangles to the number of matches. This time they're calling it the number of peaks, but the number of peaks really is the number of triangles, because what they mean by peaks is this is a peak of the triangle, 1, 2, 3 peaks, because there are 3 triangles. So let's see if we can make our own little table. So down here, drawing up a table, we are comparing peaks, which is really the same thing as triangles, with the number of matches that it takes to build it. So let's start simple. Let's start with just one triangle. If I only wanted one triangle, one complete triangle, it'd have to be this one here, one complete triangle with one peak, it would take 9 matches, 3 sides on each one, so that makes 9 matches to make that triangle. Okay, now if I want the second triangle so that we have 2 peaks, let's count on how many extra matches we've got. So 2 peaks, so 9, 10, 11, 12, 13, 14 matches. Okay, let's go one further. For the 3 peaks, we want to count on how many extra matches. So we're at 14, 15, 16, 17, 18, 19 matches for 3 peaks. Okay, so we've kind of got a bit of a pattern happening here. It says there, can you predict what is going to happen when we have 10 peaks or 10 triangles? Rather than just trying to keep counting up, why don't we try and find a rule like we did in the last question? So we want to know how many matches would be equal to. Now, in my table here, remember I said whatever these numbers are going up by is what you need to multiply by. To get from 9 to 14 to 19, I'm going up by 5. That means I'm actually doing 5 times the number of peaks. Okay, now I'm still going to have to likely add something else on. What am I going to have to add? Well, let's try. If I went 5 times by 1 peak, 5 times 1 is 5, I would have to add on 4 more to get 9 matches. Let's see if that works for 2. 5 times 2 is 10, plus 4 makes 14. It works. Let's see if it works for 3. 5 times 3 is 15, plus 4 more makes 19. So I've found a rule that works. So finally, if I want to find how many matches are needed for 10 mountain peaks, we want to use our rule for 10. 5 times 10 is 50, plus 4 more makes 54. That's the answer that we're actually after. The rest of it in green is the working out on how I got there. All right, so just like the last extension work that we did, there's no worksheets. You need to use your textbook for these ones. So you're doing exercise 8J and these questions here. All right, good luck. Catch you later.